What I'd like to do in this segment is to talk about an example that will run through the course, and this is an example of two-dimensional pictures. I'm introducing this for a number of reasons. It's a different example from looking at numbers, and also it's an example where we can build more than one implementation of a particular model of pictures. Let me show you what I mean. What we can do with pictures is make a number of transformations of basic pictures. So for example, here we've got a function flipv that flips a picture in a vertical axis. So it flips it in that axis. We've got another function fliph that flips it in a horizontal axis. And here you see a function that inverts black and white. It takes the negative of a picture. So those are three operations to take one picture into another. But we've also got operations that build bigger pictures from smaller ones. So we can put one picture above another. Here's an example of that. And we could also put one picture beside another. And you can see an example of that here. And again, you see at the top, the type picture, arrow, picture means that beside takes two pictures, you see on the left, and produces an answer which is a single picture. So that's the model that we have. And let's run through a particular exercise. So we start off with a horse. That's the black horse on a white background. We've got these functions to flip in a horizontal mirror, flip in a vertical mirror, to invert the colors, and we can put one picture above another or one picture beside another. So what we want to do is try and build the picture there. Now as I said, the horse is the image on the left. How can we produce the image on the right? Well, one way to do it is to invert the colors and then to flip in a vertical mirror. Or in fact, what we could do is do it the other way around. We could flip in a vertical mirror and then invert the colors. But one way of getting the image on the right is to invert and then flip. And to get the image itself, what we have to do is put the horse on the left beside the inverted flipped horse, which is on the right. And that's what we're doing here. We're applying beside to the horse and the image on the right. Now, one particular piece of notation that people use in Haskell an awful lot, so I want to show it right from the start, is beside is a function, and what we do to apply a function in Haskell is to put the function and then its arguments one after another. There is an alternative for a two-argument function. We can put it in back quotes and put it between the two arguments. So here we're saying we've got a horse beside the flip v inverted horse. And one last thing before we try this out. If we want to show a picture, we use a function render, and that pops up a browser window and it shows that picture in the browser window. So if you want to do that, that's what we type. We render that. Okay, let's get started having a look at doing this in practice. Here we are, we're inside Visual Studio Code. We've got, we're in our test file, and what I'm going to do is import pictures SVG. I want to import that because I want to use the functions from there, and then I'm going to describe my picture, and it's to say pic equals, and it was, if you remember, it was the horse, back quote, the flip v of invert of horse. So there we have our definition, and in fact we don't need to include those outer brackets because as you remember, function application standard function application binds more tightly than anything else. So now let's go into ghci. We load the test.hs. So importing pictures, and you can see it's I've got the editor set up. It tracks which functions I'm using from pictures SVG. It will import those, and I'm allowed to use those functions in making definitions inside test. But let me first of all save the result here, and then we can load this, and then we can render pic, and we see the picture of the ordinary horse on the left and the inverted flipped horse on the right. Okay, one other thing I wanted to say, and that is that we can write the application of render to a picture in a slightly different way. If we hadn't named the picture, we could say render and bracket the whole of this expression, and that will have the same effect. So we apply the function render to that whole expression. What people use a lot in Haskell, and it's again, I want to show this early, I don't always use it, but if you read other people's code, you will find this a lot, is that you can instead type this, render dollar, and then the expression on the right without brackets. And that has the same effect. So writing dollar here is the same as putting the parentheses around the second argument. And that's because this is a way of saying, it's an infix operation that says like plus or a backslash black quote beside, that says apply the thing on the left to the thing on the right. And now that seems silly because you can do that just by writing them next to each other, but using the dollar means you don't have to put the parentheses around. Now that may seem a trivial point, but as I said, it's something that a lot of Haskellers make an awful lot of use of. So if you're reading anybody else's code, you will often see this. And remember, if you see something like render dollar something, that's the same as render brackets, whatever follows, close brackets. Okay, let's get back to our presentation. And there you are, there's render applied there, and I've put a note in the slides to show that this is the notation that gets used. And you've seen it in action already in ghci. So there's our first example. Let's look at another example. How could you make this more complicated picture? Well, what have we got at the top? What we've got at the top is what we had before. So we've got the black horse and the reflected white horse. How do you think we can make the whole picture? What does the bottom line look like? How do we get the bottom line? Well, one mechanism is to say, let's start from scratch. We could take a black horse and invert it and put it next to a black horse that's been flipped. But I want to be lazy, and I've noticed that the bottom line is just an inversion of the top line. So I can make the whole picture by saying this is pick 1 above invert of pick 1. And that will make us the picture. Let's have a look at that. I call that pick. Let's call it now pick 1. And we have pick 2 is pick 1 above, missing the equal here, that's not very good, is above invert. Whoops. Of pick 1. Okay. And you can see again my editor is suggesting I give a type for these, and if I click on that it will in fact include that as a type in the file. So let's take a look at, now we've got a definition of pic2. We'll save this and let's reload the file, and then we can render pic2. See what we get. And indeed, we're getting what we would expect. Okay, so going back to the presentation again, we've seen the picture there. Finally, I want to leave you by asking you to work out how you would make the pictures that we see there. And you will find with all of them there are multiple ways. You could try 3 different ways of making each of the 3 pictures. And it will give you an exercise in applying functions, in making definitions inside ghci, making it inside ghci, or more properly inside an editor which you then use in ghci. It will allow you to try those out interactively.